Just y'all, just math y'all. There we go. How are you? We're going to do 4, 4, and 4, 5 today. And so here we go. No, wait a minute. We're going to do 4, 5, and 4, 6. Section 4, 5, and 4, 6. We're multiplying polynomials today. So here we go. Um, we will be using one of our exponent rules. This is the product rule that says when you multiply, you actually add the exponents. And so for this first little part, just a reminder of what that looks like. We're going to multiply. We have 21. That's the 3 times the 7. And then x to the 4th times x to the 3rd is x to the 7th. So just in a nutshell, we're going to multiply the big numbers and add the little numbers. Also, we're going to use the distributive property. You may be familiar with the distributive property where I take that 3x and multiply it by everything in my parentheses. And so that first one's going to be 6x to the 2nd, because an x times an x is x to the 2nd, y'all. So 3 times 2 is 6. X times x is x to the 2nd. Add the little numbers. There's little bitty ones right there. And then plus 21x. Okay. Also, we're going to have to combine some like terms in our problems. This is not actual multiplication. This is just a reminder that combining like terms, those are like terms, and we can combine those to get our answer as simple as possible. And so that would just be combining like terms. Okay, so on this first one, we're going to have a 10x to the 9th. Multiply the big numbers, add the little one. And then this one over here, we're going to distribute. That's going to give me a negative 54x to the 4th plus 18x to the 3rd minus 36x. Remember, there is an exponent of 1 on a variable that doesn't have an exponent. Okay, so now let's jump into some really hard ones. Okay, so now this is actually the same problem written two different ways, a horizontal method and a vertical method. I'm going to do both methods because some people love the vertical method and think, why didn't anybody show me that? And the horizontal method is the more traditional method, and I just want you to see both. And you just decide what you want to do. You can actually combine the two methods if you like and make something that's kind of vertical and horizontal at the same time. All your problems are going to be presented in the horizontal fashion. So we're going to do that one first. And we are going to do distributive property. So now in this situation, the way the distributive property is going to work is that we're going to take the 3x and multiply it by all three of those. And then we're going to come in and take the 2 and multiply by all three of those. And then, if we have like terms, we'll combine them. So here we go. That's the plan. So I'm going to do the green multiplication. So 3x times 5x to the 2nd. I'm actually going to do it. 15x to the 3rd. I'm not going to write it down and then do it because that would be like a computer doing your problem. And then I would say, somebody's writing down more than they need to. All right, then I'm going to do plus 24x to the 2nd plus 21x. So that's the three green multiplications. Then I'm going to do the orange ones. So it'll be a plus, a positive 10x to the 2nd, a positive 16x, and a positive 14. Now, I did this problem a few minutes ago and I made a mistake. So I'm going to come in and make sure I did it right this time. So it's always good to check and double check to make sure everything went correctly. So 15x to the 3rd, 24x to the 2nd, 21x, 10x to the 2nd, 8x to the 1st, and 14. Okay, so now I'm going to combine my like terms. And let's see. Combine like terms. This is just adding and subtracting. The first one, the 15x to the 3rd, doesn't have anything that is alike. But the x squareds, I have two of those. And so that's going to give me, my bad, that's going to give me a plus 34x to the second. And then that's going to give me a plus 37x. And then this one doesn't have an alike term, so that'll be plus 14. And that's my final answer. Okay, so now over here on the other side, I'm going to do the exact same thing, but I'm going to do it in a vertical method. Do it in a vertical method. Sorry, keep hitting buttons I don't want to hit. Okay, so this time, when you do multiplication like this, you start with the first number and you go like this. This is the same way you multiply regular numbers like you did in grade school. So I'm going to do 2 times 7 and get 14, and that's a positive 14. I'm going to do 2 times 8x. It's positive. Positive times a positive be 16x. And then 2 times 5 is a positive 10x to the second. Notice I am using the same color so you can see that the same numbers are coming up. They're just written in a different order. So then the next thing you do in grade school is you actually put a 0 here sometimes, called a placeholder. And so you kind of scoot over and then you do your multiplications. And so then that'd be 3x times 7, which would be a 21x. And notice the like terms are lining up. Now, if they weren't alike for whatever reason, we would not line them up. We would give them their own individual column. Like terms must always be in the same column when we're doing things vertically. All right, and then I'm going to have 24x to the second. Again, like terms. And then last, we'd have 15x to the third. And then, if you don't remember, you add them up. And again, we're combining like terms. And notice, because of the way we did it, they're all lined up. And so this would be 14. And this is going to be 37x. And that's a plus 14. And that's a plus 37x. And this is a plus 34x squared. And the 15x to the third. So you can see that my final answers are the same. And so either method is up to you. I like the vertical method when the problems get really, really big. And I like the horizontal method when the problems are smaller. So it does not matter. Just wanted to show you both methods. Okay, so the next page, here we go. I'm going to put these problems up. I'm going to stop this video and come back and start this one over again. But if you want to go ahead and copy these down, and then you can work on those while I get this other video ready to go.